All right, so the do now right now is just asking what is the shape of this stop sign, and hopefully you guys will remember that the shape of this stop sign is an octagon. Okay, so this is not a quadrilateral. This is going to be a different type of polygon, and today we're going to learn all about polygons, but we will relate it back to triangles and back to quadrilaterals off of things that we know. So to start off, um, we have open and closed polygon. Okay, so a polygon is a closed figure. So obviously there's no openings. Here's an opening. We don't like those. So a polygon is a closed figure that is the intersection of line segments in a plane. And a polygon has the same number of sides and angles. Just like with a triangle, it has 3 sides and 3 angles. A quadrilateral has 4 sides and 4 angles. There are different types of polygons. There are concave polygons and then convex. Concave have like these divots, okay, while convex does not. And the exact thing would be if I was to go from corner to corner to make a diagonal, if I look at the convex, these are all the different diagonals that I could have coming from this one point. None of these diagonals go on the outside. But if you look here, if I draw this diagonal, it's on the exterior of the shape. So here, concaved has those diagonals that come on the outside. So basically, if it doesn't have a little divot inside, that is concave. Convex has no divot. What is the smallest polygon that you can have? So what is the smallest closed shape figure that you can have? And your answer is the triangle, which is the building blocks of all of the polygons we're going to learn about. Now, what is most important is things that you have to be responsible for, which is the names of these shapes. You have to know the names of these shapes. So if I say triangle, then you know that the number of sides is 3 and the number of angles is 3. Okay, coming from a quadrilateral, you know that it is a 4-sided shape. A 5-sided shape is known as a pentagon. A 6-sided shape is known as a hexagon, while a 7-sided shape has 2 names. It's either referred to as a septagon or a heptagon. Our 8 sides is known as an octagon, while a 9-sided shape also has 2 names. It's known as a nonagon or a novagon. Okay, not a nineagon. I will not accept nineagon as an answer. A 10-sided shape is known as a decagon. An 11-sided shape is either known as a hen decagon or an un decagon. Hen and un meaning 1 and then the 10, which then makes a 12-sided shape known as a dodecagon. Okay, anything above that we would say like a 13-sided shape or 15-sided shape, etc. But these are all the different names of your quadrilaterals, and you are responsible for knowing the names and matching the names to the number of sides. So we have talked about this before, but a polygon is considered equilateral, equal in sides, if all of its sides are the same length. It's considered equi, which is equal, and then angular, which is your angles, if all of their angles are equal. So a regular polygon is a polygon that is both equilateral and equiangular. So when we are talking about triangles, is an isosceles triangle a regular polygon? And the answer is no, that's false. Okay, what is the regular polygon for three-sided shapes? Well, it's an equilateral triangle because the equilateral triangles are always equiangular. So that is considered a regular shape. That is the only time that a polygon is equilateral and equiangular at the same time. It's the only shape that that happens with. Is a rhombus a regular polygon? Well, the answer is no. Only its sides are congruent, not its angles. So that is false. What would the regular polygon be for quadrilaterals? A square. A square has all four sides congruent, making it equilateral, and it has four angles. So that is going to be a regular polygon. Okay, so here we're going to develop kind of the whole thought process on coming up with the sum of the interior angles of any shape. So I'm going to lower this to kind of make this a little bit easier to see. Okay, so here I know that this is a triangle and it has three sides and three different angles. So what does it mean by the number of triangles? Well, what I'm trying to say is that when I take a diagonal, how many triangles does it form coming from one point? So you pick one point on the polygon and you connect it to every other vertice. Well, here and then here. So there are no real diagonals in a triangle. So the only one triangle is being formed. And what is the sum of the interior angles? Well, the sum is 180. Now we have a quadrilateral. So if I look at a quadrilateral that has four sides, when I go to one of its vertices and I connect it to all the other ones, here's one, here's two, here's three. How many triangles did I form? Well, I formed two triangles. And what was the sum of the angles of a quadrilateral? Well, the answer is 360. So now I go to my five-sided shape, which is a pentagon. So this connects here, I have one here, one diagonal here, and one diagonal here. So that formed three triangles. And now what is the sum of the interior angles of a pentagon? Well, now we should be noticing a pattern. Well, for the triangle is 180, but for the quadrilateral, I have this angle, and this angle is 180, plus this, plus this is 180, making it 360. Here I have one triangle of 180. Two 180, which is 360, and 360 plus another 180 is going to be 540. Now I go for my six-sided shape, which is a hexagon. Can we guess the number of triangles that are formed in a hexagon? Well, here, when I connect each vertice that's not already connected, I am forming four triangles. And then how do I find the measure of those four triangles? Well, I add 180 plus 180 plus 180 plus another 180, and that is going to be 720 degrees. So now, how can I apply this information for any general case? So my value n, the general case of n, any sided shape, how many triangles would I make on the inside? Well, what is the pattern from the first column to the second? Well, I'm subtracting by 2. So the number of triangles inside is n minus 2. And now how am I getting to the interior angles? Well, the answer is I'm taking that 180 degrees and I'm multiplying it by how many triangles are on the inside. So that is your formula for your sum of your interior angles of a triangle. I mean, of any sided shape. So the sum of the interiors of any polygon is going to be 180 degrees times n minus 2, which is the number of triangles. N is equal to the number of sides and angles that polygon has. So if this was a pentagon, n would be equal to 5. So question says, describe how we can find the measure of one of those angles if it's a regular polygon. Well, if I want to take the total and I want to find the measure of one of them if they're all equal, okay? Well, what would I have done to find the measure of a triangle if they were all equal? Well, I would have divided them by 3, and then I would have gotten 60 each. What is the measure of one of the angles of a regular quadrilateral? Well, I take 360 and I divide it by how many angles there are, and they're each 90 degrees. The 540 I would then divide by 5, and that would get me 120. And 720 divided by 6 ends up getting me, this would be 120, this would be 108. Okay, so what am I doing to the total to get each individual? Well, I'm dividing it by how many angles it has. So to answer that question, describe how we can find the measure of one interior angle of a regular polygon. Well, I would take the total, find the sum or the total, and then divide by the number of angles. And how would I put that in symbolic form? Well, I know the sum was 180 times n minus 2, and then I would divide it by the number of angles, which is n. And you have to remember that n is equal to the number of sides and angles, because that's going to be the same number. So these are formulas to find the measure of these interior angles, the sum and the one of them if they're all equal. So now we're going to apply it to different questions. Those were regular shapes. These are now irregular. Irregular means that they are not equal. So if you had a scalene triangle and they were all different measures, 3x, 2x, and x, what would you do? Well, you would add the 3 angles up and set them equal to its total of 180. The same thing is going to apply to a hexagon. You would need to add all 6 angles up and set it equal to its total. What is its total? You have to find it. It's the 180 times your n minus 2. Your n in this case is going to be 6. So this is going to be 180 times 4, which when you put it into your calculator is 720 degrees. When I add up all the angles, 2a, 5a, 4a, 5a, 3a, and 5a, when I add them all together, I get 24a. So I added up all the angles, I set it equal to its total of 720, and then I solve for a. A is equal to 30, which now means after I plug them in, I get this angle is 60, 150, 90, 150, 120, and 150. And these should all add to 720. How would we use the sum to find out the type of polygon it is? So now when we're working backwards. So if I'm given the problem, the sum of the angles of a polygon is 1440, how many sides does it have? When I am looking for n, I set the formula equal to the answer that's given. So the sum of the angles of a polygon is equal to 1440. The formula for the sum of the angles is 180 times n minus 2, which means now I'm just solving for n. What do you do first? Well, I distribute. 180 times n minus 360 is equal to 1440. The next thing I do is I add 360 to each side. So I'm left with 180n is equal to 1800. And now when I divide by 180 on each side, I get that n had to have been 10. So that is a decagon. Okay, so this is important. Whenever it looks like it's giving me the answer, I set that formula equal to the answer. Looking back, whenever it's an irregular polygon, I have to add them up and set them equal to its total. Add them up, set them equal to its total. That you have to find. When it's a regular shape, I just find the total and I divide it by how many angles there are. And if I'm just looking for the total, it's 180 times n minus 2. So right now, you're going to finish the daily work and turn it in.